Students, today we are going to see the vibration of air column when the pipe is closed at one end. Now what is air column? What is the pipe when it is closed at one end? All this concept will get clear if you are concentrating on the diagram. So let's consider this is the pipe which is cylindrical in shape, and this pipe having a certain length. Now when we are holding a tuning fork, vibrating tuning fork, near the open end of the pipe, then this tuning fork will send the longitudinal wave, that is the sound wave. So that sound wave will be traveling through this air column. So that sound wave which is starting from vibrating tuning fork, traveling through the air column will act as an incident wave, which will incident at the closed end of the pipe. And from this closed end of the pipe, your sound wave will get reflected. So inside the air column, there will be the superimposition of incident wave and reflected sound wave. And when such incident wave and reflected wave will get superimposed on each other, then there will be a formation of stationary waves inside the air column. And when that stationary wave will get formed inside this air column, then there will be a formation of node and antinode. Because already in the property of stationary wave we have seen, stationary wave means what? It is the form of loops. And loop means what? There is an alternate node and antinodes will be formed. Clear? Now, in this pipe, at the closed end, there is a formation of a node. Now, why it is so? When your wave, sound wave, will incident through this air column on this rigid wall will act as a tensor medium. And when it will act as a tensor medium, from that tensor medium, your wave will get reflected. Now, when wave will get reflected and rigid wall is not ready to vibrate, so it will not ready to vibrate means what? At this particular point, the displacement of the rigid wall is zero. And when the displacement is zero, then that point is to be called as a node point. So here is the formation of at the closed. While at the open end. At the open end, what is the situation? Air particles are present, and these air particles, which are nearer to this open end, are free to vibrate. And when these air particles are free to vibrate, the air particle will vibrate with maximum amplitude. And when it will vibrate with maximum amplitude, here is at the open end, there is a formation of antinode. Antinode is formed means what? The vibration amplitude is cancelled. Clear? So now this antinode will be formed slightly above the open end of the pipe. Now why it is so? Because up till open end, up till boundary of open end of the pipe, air particles are in the bounded medium. But as we go above the closed end, so just above the closed end, the air particle will remain present here, but they are in the unbounded medium. So when air particles which are present in the unbounded medium, these air particles will vibrate with maximum. And therefore, there is a formation of antinode, which is slightly above the closed end, above the open end of the pipe. So that there is a certain distance between the open end of the pipe and the formation of antinode. So this distance is to be called as your end correction, which is denoted by letter E. And this end correction E is equal to nothing but 0.32, where d is nothing but the inner diameter of the pipe. And hence, I can say that therefore capital L, which is to be called as the length of vibrating air column. So this length of vibrating air column, this is nothing but the capital L. So this capital L is equivalent to small l, which is the length of the pipe, plus E, where E is nothing but the end direction. Clear? So in this manner, I can write the length of air column when your pipe is closed at 1 feet. Is it right? But if I am considering another case, that is if there is a pipe and this pipe is open at both the ends. So I can consider this is a pipe. This pipe has a length small l, and now this pipe is open at both the ends. And near the open end, any one of the open end, when I am holding a tuning probe. So what happens? This tuning probe will send the sound waves. And these sound waves are traveling through this pipe. But here is other end is also open. Other end is open means what? Other end will act as a error medium. Means your sound wave is incident on a error medium. It is traveling through the boundaries of the pipe and it is ended on the error medium. So in the error medium, the air particles are free to vibrate. Therefore, at the other end of the open end of the pipe, there is a formation of antinode. So antinode will form. And at the upper end also, the air particles are free to vibrate. So there is also a formation of antinode. But in both the cases, in case of both the ends, your antinode will be formed not exactly at the open end, but it will be formed slightly above the open end. And this distance between no antinode and the open end is to be called as your end correction. So one end correction I am getting at the upper open end and other end correction factor I am getting at the lower end. And in between these two antinodes, the air column is going to be vibrate. Means in this particular case, what I can say that L, that is length of the air column, which is nothing but small l, that is the length of the pipe, plus 2 times end correction. Why end correction will be added 2 times? Because in case of pipe, which is open at both the ends, there will be a formation of antinode at the upper end and formation of antinode at the lower end. So 2 antinodes will be formed. And antinodes are situated slightly above the open end. And the distance between open end to the position of antinode, that is nothing but your end correction. And that's why as 2 antinode, one antinode is above, another antinode is below. So that distance, upper corresponding distance is end correction, lower corresponding distance is end correction. Therefore, 2 end corrections will get added to find out the length of air column. So this thing you have to note down very carefully. That is when pipe is closed at one end, at the closed end there is a formation of node, and at the open end there is a formation of antinode. And therefore, your capital L will be nothing but small l plus E. And when pipe is open at both the ends, at that time, your length of air column, capital L, is equal to small l plus E. Getting? And now using this concept, now we are going to see the different modes of vibration. When your pipe is closed at one end, so now we are going to discuss about the different modes of vibration of air column when pipe will be closed and one thing. So let's consider these different modes of vibration. In this different mode of vibration, the very first concept I will say that pipe which will be closed at one end, length of the pipe is small l. At the open end, tuning fork will be L. So the tuning fork will be sending the sound waves. That sound wave will get reflected from the closed end. While closed end is rigid support, so it is not free to vibrate. As it is not free to vibrate, node will be formed at the closed end and antinode will be formed at the open end. Node will be at the closed end because closed end is not allowing to vibrate, so displacement is 0. While at the open end, air particles are in the unbounded medium, so air particles are free to vibrate. Therefore, antinode will be formed at the open end. Clear? And when antinode will be formed, so in stationary wave pattern, when antinode will be formed, I can show the loop formation in this manner. That is, half loop will be formed. Means what? Here is a formation of one node, one antinode. And these node and antinodes are consecutive. Means what I can say here, this corresponding distance from open end to antinode position, distance is nothing but E. L is nothing but the length of the pipe. So your capital L can be written as L plus small e. And what that capital L? Capital L is nothing but the length of vibrating air column, which is nothing but the consecutive distance between antinode and node. As it is a consecutive distance between antinode and node, so consecutive distance between node and antinode, which is nothing but your lambda by 4. That you have seen in the properties of station. Getting? So now what I will write down here, length of air column is equal to lambda by 4. Fine? And hence I can write down velocity of sound wave. V is equal to nothing but n lambda. Now if this V is equal to n lambda, I can write down frequency is equal to V upon lambda. Fine? As it is V upon lambda, I can write down V upon. Now from here, I can write the value of lambda. What is the value of lambda? I will get it 4 into L. So that value of lambda I can substitute as a 4L. Means what I am getting that your air column is vibrating with frequency N, which is equal to nothing but V by 4. Or we can say that capital V divided by 4 into L plus small l plus. So this is to be called as your fundamental frequency of an air column when pipe is closed at 1 km. So here is nothing but you are getting as a fundamental frequency. Clear? So this fundamental frequency N, which is equal to V by 4L, or it is equal to V divided by 4 into small l plus. So this is nothing but called as your fundamental frequency. So I can denote this as a NF when one end is closed. So NFC, fundamental frequency when one end of the pipe is closed. Clear? Then now I can see here the second mode of vibration. Again same consideration. Pipe is closed at one end. So node will be formed at the closed end Antinode will be formed at the open end. But now, here your air column is vibrating in the second mode of vibration. So this air column is vibrating in the second mode of vibration. So in the second mode of vibration, what I can say that here will be the formation of, I can say here is nothing but the formation of node, and at the open end, there will be the formation of antinode. Means here one complete loop and the upper part is nothing but the half of it. 1/4, half of it. So this distance now, this total distance. In this total distance, one node is formed at the closed end, another node will be formed inside the air column, and here is inside the pipe there is an antinode, and outside the pipe there is an antinode. Means now in the second mode of vibration there is a formation of two nodes and two antinodes. So two nodes are formed, two antinodes are formed. Is it right? Now due to formation of these two nodes and two antinodes, what I am getting that your length of air column L can be written as, now see here, one complete loop, and length of one loop is nothing but your lambda by 2. Right? But here I am getting second mode, so wavelength is definitely different. So I will call it as a lambda dash by 2 plus this half part of the loop. Half part of the loop is lambda dash by 4. Means I am getting here total length is nothing but 3 lambda dash by 4. Get it? So what I say here, lambda dash is equal to 4L by 2. This is nothing but your lambda dash. Now this lambda dash value I can substitute in the frequency formula. What is your frequency formula? I can say frequency N1, right, is equal to V upon lambda dash. Get it? So V upon lambda dash, so what I will say here, V, lambda dash value is of 4L by 3. So here I am saying 4L. 3 factor will goes to the numerator. Means in short what I say that N1 is equal to 3 into bracket V by 4L. And if I am saying this is the fundamental frequency as the N, so what I am saying that it is equal to nothing but 3N. Because V by 4L is nothing but your fundamental frequency N. So what I am getting this second mode frequency, which is nothing but the integral multiple of 3 to the fundamental frequency. So N1 is equal to 3N. So 3N, that's why this frequency is to be called as a third harmonic frequency. Third harmonic frequency, or it is to be called as the first overtone frequency. So it is called as a third harmonic frequency, or it is called as a first overtone frequency. Why third harmonic? Because N1 I am getting, which is equal to product of 3N. N is the fundamental frequency. N is multiplied by 3. So it is third harmonic frequency. Or it is to be called as your first overtone frequency. Clear? Means what? I will write in the corner fundamental frequency when the pipe is closed at one end, which is equal to V by 4L. First overtone frequency or third harmonic frequency, which is N1 is equal to 3N, or N1 is equal to 3 into bracket V by 4L. That I am getting. Clear? Now, here I can say the third mode of vibration. So this is first mode of vibration. What fundamental frequency I am getting? N is equal to V by 4. Now I will draw the diagram for third mode of vibration. In the third mode of vibration, what I can say again, I will draw a pipe of length L. Vibrating tuning probe will be held at the open end. So antinode will be formed at the open end. Node will be formed at the closed end. And this is what? Third mode of vibration. Third mode of vibration means the wavelength of sound waves are definitely different. So number of loops formed will be different. But what is the condition? Node should be formed at the closed end. Antinode should be formed at the open. So what I say here, I am going to draw now here these two loops. Okay, here I am giving this two complete loop and half loop will be outside the after this. So now, how many nodes? Node, maximum amplitude, antinode, again node, antinode. No. See that how many nodes are formed? How many antinodes are formed? Nodes 1, 2, 3. So 3 nodes. And if you are seeing carefully in the diagram, 3 antinodes. That will get formed. So see here now equivalence. Fundamental frequency. 1 node, 1 antinode. Second mode of frequency. 2 node, 2 antinodes. Third mode of vibration. 3 node, 3 antinodes. So यहाँ पे this type of MCQ also asked. If 3 nodes and 3 antinodes will be formed, the air column where pipe is closed at one end is vibrating in which frequency? Or the question will be, if the pipe is closed at one end, in the third harmonic vibration, how many nodes will be formed? How many antinodes will be formed? The third harmonic, 2 nodes, 2 antinodes. Fundamental mode, 1 node, 1 antinode. But in which case? When pipe is closed at 1. Clear? Then, now in this I have to explain about this element. How many loops? 1, 2 and half. These 2 and half loops will be formed. This is what I say, length of the air column, L, is equal to first loop length, lambda dash by 2. Second loop length, again lambda dash by 2. Plus half loop, lambda double dash by 2. Why wavelength is changed? Because it is a different mode. So wavelength of the sound wave will go down, change. So what I write down here? L is equal to, just do the addition. Lambda double dash by 2 plus lambda double dash by 2, that is lambda double dash, plus lambda double dash by 4, which is equal to 5 lambda double dash by 4. Means your lambda double dash can be written as 4L by 5. Clear? So now I can write down frequency by which air column is vibrating. That is N2. So this frequency N2, which is equal to nothing but V divided by lambda double dash, which is equal to V divided by 4L by 5. Means what I write down here? N2 is equal to 5 into 4 by 4, 5 into V by 4L. And V by 4L is nothing but your fundamental frequency. So what I write down here? N2 is equal to nothing but 5N. So N2 I am getting 5N. N1 I am getting 3N. So when it is 3N, I am saying third harmonic. So when I am getting N2 is equal to 5N. So which is the number of harmonic? 5N. So it is what? Fifth harmonic frequency. So this N2 is to be called as the fifth harmonic frequency, or I can say that it is the second overtone frequency. So these are nothing but the different modes of vibration. Now, in this different mode of vibration, if I write the conclusion, what I will say that fundamental frequency V is N is equal to V by 4N. This is the fundamental frequency when the pipe is closed at one point. How many nodes are formed? One node, one antenna. Second mode of frequency. It is vibrating with first overtone, so N1, which is equal to 3N, which is equal to 3 into V by 4N. How many nodes are formed? Two nodes, two antennas. Then next, third mode is vibrating with second overtone frequency, second overtone frequency, N2 is equal to 5N, which is called as the fifth harmonic, which is equal to 5 into V by 4. How many nodes? How many antinodes? 3 nodes. 3 antinodes will be formed. Clear? In which case? When the pipe is closed at one plane. So when your pipe is closed at one plane, what the picture I am getting here, in all three modes, first mode frequency is N. In second mode frequency is N1. In the third mode frequency is N. Now if I take the ratio, see that this. Fundamental frequency N. N1 is 3N. N2 is 5. So from all three factors N will get cancelled. What I am getting 1 as to 3 as to 5. 1 odd number, 3 odd number, 5 odd number. Means what conclusion I can say that? Vibrating air column when pipe is closed at one end vibrate only with odd integral multiple of fundamental frequency. I'll again repeat my sentence. When pipe is closed at one end, air column is vibrating with a frequency which is equal to odd integral multiple of fundamental frequency. Getting? N is called fundamental, 3N is called third harmonic or first overtone, 5N is called fifth harmonic or second one. Got it? So this is about the topic vibrating air column when the pipe is closed at one end. Now for this topic, how you have to study the topic? First thing is you have to concentrate on the three diagrams. First mode diagram, second mode diagram, third mode diagram. That is the first question. For 2 marks. Draw neat level diagram showing vibration of air column when the pipe is closed at one end. In this diagram, what the thing is important we have to show? You have to show the location of node and location of antenna. And for node, A for antenna. This is the first question. 2 marks. Second important question is what? Derive expression for fundamental frequency when air column is vibrating in a pipe closed at one end. Means your first diagram. From diagram you can write wavelength. From wavelength you can write frequency. That is fundamental frequency N is equal to V by 4. Got it? This is second 2 mark question. Now, next 3 mark question. What is that? Show the different modes of vibration of an air column when the pipe is closed at one end. So all 3 diagrams, all 3 frequency direction. N, N1, N. This is 1. Or for this, or question is, show that when pipe is closed at one end, air column is vibrating with odd integral multiple of fundamental frequency. Means you have to find out, you have to draw all three diagrams, you have to derive for n, you have to derive for n1, you have to derive for n2, and finally you have to write this conclusion. That is n as to n1 as to n3 is equivalent to 1 as to 3 as to 5. Is it consists of only odd integral multiple of 3. Got it? Okay, then very short answer. And MCQ. So many very short and so many MCQ. In MCQ, for each node, how many nodes are formed, how many antinodes are formed? Or one node and one antinode is formed in which mode of vibration when the pipe is closed at one end? So which mode? Momentum. Suppose I am saying that here 5 nodes and 5 antinodes are formed. Let's see. 5 nodes and 5 antinodes are formed. So corresponding frequency is to be called as what I am saying N4. That is fourth ortho frequency. Here is N2, second ortho, right? Second ortho, but how many nodes and antinodes are formed? In 2 you have to add 1. Means 3 node and 3 antinodes. Similarly, if node and antinodes are given, I will subtract 1. So that is your ortho frequency. So what I am saying? N4. N4 is a fourth ortho. Fourth ortho is equivalent to which harmonic? That is 9n. That is 9th harmonic frequency. So fourth ortho is equivalent to 9th harmonic frequency. Like that manner, there may be some MCQ questions or very short MCQ questions. Clear? Or sometimes might be there is a ratio. Ratio of first to second ortho. First ortho is 3n, second ortho is 5n, so ratio is 3 as to 10. Like that manner there is a question. Only one thing you have to remember, number of ortho. Fourth ortho. How many node and antinode? फोर्थ ऑर्डर में इसमें एक ऐड करना है. 4 में एक ऐड किया तो कितना होगा 5. मींस हाउ मेनी नोड एंड हाउ मेनी एंटीनोड? 5 नोड एंड 5 एंटीनोड. अगर मैंने बोला 7th ऑर्डर तो कितने नोड एंड कितने एंटीनोड? नंबर इज 7, इसमें एक ऐड करोगे मींस 8. तो 8 नोड एंड 8. Are you getting? So like that manner, just by common sense, you have to remember it. Are you getting? Okay, suppose now, if I am going to ask a general question. If I say that when the pipe is closed at one end, the peak ortho frequency, air column is vibrating with peak ortho frequency, then how many nodes and how many antinodes will be formed? What is that? Ortho number कितना है? P. इसमें एक ऐड करो. मींस एंटीनोड कितने फॉर्म होंगे? P plus 1. नोड कितने फॉर्म होंगे? सेम P plus 1. तो ये हो गया मेरा जनरल एक्सप्रेशन. Clear? Any doubt here? Are you getting the things? So this is about your vibrating of air column when the pipe is closed at one end. Okay, so today I'll stop the lecture. Next time we can see the next topic. Fine, thank you.